Hi, welcome to Mathematics of Chemistry Part 4. My name is Dr. English, and today we're going to be talking about scientific notation and significant figures. Specifically, we're going to be asking ourselves the question, why scientific notation? Why do we need scientific notation in chemistry? Converting standard notation into scientific notation, a little bit of practice, converting scientific notation into standard notation, and then ending with a little practice after that. What is scientific notation and why do we use it in chemistry? Scientific notation is a way to abbreviate either very large or very small numbers, and in chemistry we definitely use some very large numbers and some very small numbers. Scientific notation is used in chemistry with working with numbers like Avogadro's number, which you'll learn more about, which is this big number right here. So 602 septillion, actually, if you want a word behind it, more commonly refer to it as 6.02 times 10 to the 23rd. And if you'd like to learn more about the origins of Avogadro's number, totally encourage you to watch the TED Ed animation on how big is a mole. Absolutely brilliant. Another number used in chemistry is the charge of an electron. So you can see this negative right here because we know electrons are negative, and it's basically that many coulombs, which is really, really, really tiny. So instead of writing out all those zeros all the time, we represent it as negative 1.602176 times 10 to the negative 19 coulombs. Much easier to write it like this rather than all of these zeros. So that's the reason why we use scientific notation. We just really don't want to write such very large or very small numbers. Converting standard notation into scientific notation. Now, there's a very specific format that we're going to use when we take just a regular number and we put it into scientific notation. So for a number written in scientific notation, the general format is the A is going to represent our numbers that we're actually going to see times 10 to some power. So how do we set this up? When converting a standard number into scientific notation, this symbol A has to be at least 1 but less than 10. So steps for writing a standard number in scientific notation. This is the example that we're looking at right here. I want to get that into scientific notation. Identify the significant figures in the number. So we know that there's a decimal point, so we're going to start over on the left-hand side, our Pacific side. We're going to go across until we hit our first non-zero numbers, which is right here, and that and everything afterwards will be significant. So these are our significant figures right here. We want to rewrite the number with one digit in front of a decimal point and the rest of the numbers after the decimal point. So we're going to take these numbers right here. We're going to take that first number and put it in the ones position, then a decimal, then the remaining numbers following that decimal point. The next step here is to determine the exponent to use. Now we're at the point where we need to figure out what is the exponent that we're going to use. So we're going to start out by counting the number of places you must move the decimal point. We've got to move the decimal point in order to get back to where the decimal point was originally located. Now, if you have to move the decimal point to the right, going to the right to get to the original number, then write the exponent as a positive number because you have a number that is going to be greater than 1. If you have to move the decimal point to the left to get the original number, then write the exponent as a negative number because now you have a number that is less than 1. So let's examine the original number given here. It's 0.0000008245. What we did is we identified our significant figures. We took those numbers, we put the larger one in the ones position, we put our decimal point in, and then we wrote 245. Now, to figure out whether we need a negative exponent or a positive exponent, we're going to say, well, here's our decimal. So here's our decimal over here. What do we have to do to get it back to its original location? So we need to move that decimal over to the left. which means if we have to move the decimal point to the left, we're going to write our exponent as a negative number because obviously this number is less than 1. So now I'm going to count. So we're going to do 1, 2, 3, 4, 5, 6, 7. So when I write this out in scientific notation, it's going to look like this. 8.245 times 10 to the negative 7. And that negative means that our number is less than 1. Let's look at 2 examples here together as we convert the following from standard notation to scientific notation. Then when we get to the practice, I want you to stop, try them out on your own, and see how you do. So our first example is 50,000. To put this into scientific notation, we're going to put a decimal right here, and then we're going to have basically our multiplication sign, the 10, and then a positive exponent. So here's our 5. Here's where our decimal point is located. I put 2 zeros afterwards. You don't have to do that. You could just write it as 5 times 10 to the 4th. The big thing to notice here is that we have a positive exponent because this number is greater than 1. Let's look at our next example. We have 0.000002. So when we write this, the 2 is going to be in the ones position, a decimal potentially, and then a 0 afterwards, or just 2, the times sign, the 10, but now our exponent is going to be a negative number because this number is less than 1. So if we had to count, we'd start right here, and we'd say 1, 2, 3, 4, 5, 6. So when we write this number, it's going to be 2 times 10 to the negative 6 because this number is less than 1. So now what I'd like you to do is stop, pause the video, practice these, see if you can write them out in scientific notation, and then we'll see how you do. Welcome back. Let's see how you did. So our first one here, 230,000. This is a number that is greater than 1, so we're going to put our decimal right here, and then we're going to count to the right. So 1, 2, 3, 4, 5. So when we write this out, it's going to be 2.30 times 10 to the 5th, a positive exponent. Let's look at the next one. 4.65, we're going to put our decimal point right here, and then we're going to count to the right. 1, 2. So when we do this, our answer will be 4.65 times 10 to the 2. Let's look at our next example. We have this very large number right here. Ultimately, we're going to put a decimal point right here. So let's count over to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our answer here will be 3.47 times 10 to the 11. Okay, let's look at our next example. So we have 48.95, and we want to put that in scientific notation. We need to have one number, which is the 4, in our ones position. So we're just going to move that space 1 over to get back to our original decimal point. And again, we are moving it to the right. So our answer for this one is going to be 4.895 10 to the 1. Now let's look at a different situation. These are numbers that are less than 1. Again, we go across until we hit our significant figures, which are right here. I'm going to put my decimal point right here because ultimately I want that 2 in the ones position. And then again, I'm going to count, but in this time I'm going to count to the left. So we're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So when we see this number in scientific notation, it's going to be 2.36 times 10 to the negative 13 because this number is less than 1. Let's look at our next example. We have 0.000033. Again, we find our significant figures. I'm going to put a decimal point right in between, and I want to count to get back to my original decimal point. So I'm going to put this over 1, 2, 3, 4, 5. This is moving to the left, so my exponent will be negative. So this is going to be 3.3 times 10 to the negative 5. Okay, now let's talk about converting scientific notation into standard notation. If the exponent is positive, move the decimal to the right by the number of the exponent. So here we have in our scientific notation 1.23 times 10 to the 4th. we're trying to get to our standard form. So if we have 10 to the fourth, we're going to move it to the right. So we'd say 1, 2, 3, 4. And those little bumps there would be put in by 0 placeholders. And that's why we have these zeros right here. 4.91 times 10 to the third. Again, we're going to move it over 3 places. So 1, 2, 3. We're going to have a 0 right here. And that's why we see that 0 on the end. If the exponent is negative, then you move the decimal to the left by the number of the exponent. So 2.1 times 10 to the negative 3. I'm going to move that decimal place to the left. So 1, 2, 3. That's going to establish my new decimal place in my standard notation. And I'm going to replace those little bumps with 0, which is why I get 0.0021. Then finally, 1 times 10 to the negative 6. We're going to assume that there is a decimal right here. Again, my exponent is negative, so I'm going to move it over to the left. So 1, 2, 3, 4, 5, 6. Right here, fill these spaces in with zeros. 1, 2, 3, 4, 5, which is why I have 5 zeros over here. So again, let's do a little practice together, and then I want you to try some on your own. 7.1 times 10 to the negative 2. It's a negative exponent. So I'm going to take that decimal and I'm going to move it over 2 spaces to the left. So 1, 2, establish my new decimal, put a 0 right here. So I should get the answer of 0.071. The next one, 2.384 times 10 to the 9. The 9 is positive, so I'm going to end up taking this decimal over 9 spots. So my final answer for this one will be 2384, and then a bunch of zeros. So now what I'd like you to do is stop, practice these, and come back and check your work. Welcome back. 1 times 10 to the fifth. The fifth is a positive number, so there's an assumed 1 right here. So basically what we're going to do is write 5 zeros, and there's our 5 zeros right here. 4.65 times 10 to the fourth. We're going to move our decimal point to the right. So 1, 2, 3, 4. Replace those spots with 0. So we're going to get 46,500. 2.5 times 10 to the 11th. So we're going to move this over 1 and then add on 10 more zeros. And we get this very large number right here. Now we switch to a negative exponent. And remember, when you have a negative exponent, to get back to the original location of the decimal, we're going to move it over to the left. So here's my decimal, and I'm going to move it over to right here. So 1 spot. So that's why that's 0.5904. 3.47 times 10 to the negative 10. I'm going to move this decimal point over 1 spot and then add on 9 more spaces to the left. So I'm going to have this very small number with 9 zeros, the 3, the 4, and the 7. Finally, 8.7 times 10 to the negative 7. Again, it is a negative exponent, so I'm going to move it over to the left. So it's going to move it over 1 and then 6 more times. So I'm going to have 6 zeros, 8, 9. So what did we learn in this little tutorial? We went over why do we use scientific notation in chemistry. We talked about converting standard notation to scientific notation. We did a little bit of practice, converting scientific notation to standard notation, and then a little bit more practice at the end. Need more help? Feel free to contact me. Have a great day.